This is Food Science 571, Food Process Engineering Technology. This is your instructor, Dr. Barrett T. Vaughn of the Department of Food and Nutritional Sciences. We continue and conclude with Topic 1, Problem Solving. This is Lecture 4 of 4. We start this next section talking about energy balances. Primarily, an energy balance is a study of a piece of equipment where we consider the amount of energy that's going in, coming out, and all of the different changes that are made between different components that are within the system, which is similar to how we do a mass balance. In this particular example that we're looking at a tubular water blancher, which is a type of equipment used to heat foods up a certain amount using boiling water. The example reads, a tubular water blancher is being used to process lima beans. The product mass flow rate is 860 kilograms per hour. It is found that the theoretical energy consumed for the blanching process amounts to 1.19 gigajoules per hour. The energy lost due to lack of insulation around the blancher is estimated to be 0.24 gigajoules per hour. If the total energy input to the blancher is 2.71 gigajoules per hour, calculate the energy required to reheat the water and determine the percent of energy associated with each stream. For this particular problem, you have to consider that the water that's used for blanching will be reused, the heat that's in it will be used again, but there's a certain amount of need to reheat the water, and you are attempting to calculate that amount out. Also, you'll be determining the percent energy associated with each stream so that you can calculate the efficiency of this process. Here on this slide, we have a diagram of the system, and we also have shown the inputs, the losses, and the energy that's leaving out. Essentially, what you see at the bottom of the page is the schematic of the water blancher. The water blancher is the small box that you see on the inside of the dashed box. The dashed box actually is the system boundary. And for the purposes of this problem, we will consider energy that's input into the system as being positive, energy that comes out of the system, that is to say arrows that go outside of the dashed boundary, as being negative. And so you see that we have one positive energy input and three negative energy losses. Energy loss from surfaces through insulation, energy leaving with the product, that would be the lima beans, and then energy leaving with the water, which would be the energy that would be recycled for the next set of lima beans to be processed. And now on to the solution of the problem. We first collect what we have as given information. And here we know the product mass flow rate, which is 860 kilograms per hour, the theoretical energy required for the product, which is 1.19 gigajoules per hour, the energy lost due to lack of insulation, which is 0.24 gigajoules per hour, and energy input to the blancher total, which is 2.71 gigajoule per hour. In the approach, we first write an energy balance and then solve for the unknowns. First, we need to select 1 hour as a basis. Everything is given in terms of hour. And then we do an energy balance, may be written as follows. The energy input to the blancher is equal to the energy out with the product plus the energy lost due to lack of insulation plus the energy out with the water. Substituting appropriate values in an energy balance will give you 2.71 gigajoules per hour is equal to 1.19 gigajoules per hour plus 0.24 gigajoules per hour plus the energy out with the water, which is denoted by your E subscript W. We get, essentially, when you solve this, E subscript W, which is the energy lost out with the water, is 1.28 gigajoules per hour. The solution then goes on to say, thus the blancher requires 2.71 minus 1.28, which is equal to 1.43 gigajoules per hour to both reheat the water and maintain it at conditions necessary to accomplish the blanching process. In essence, that is the amount of energy that you will need to return to the water for it to blanch another set of lima beans. Next, we consider the answer to the second part of the problem in converting the above values to percentages of the total thermal energy input. The total amount, or the total thermal energy input in this case, is the energy in, which is 2.71 gigajoules per hour. The energy out with the product, as you see on the first line, is 1.19 gigajoules per hour. And once you divide that and multiply it times 100, we get 43.91%, which is the amount of energy that actually went out with the lima beans. The energy loss due to lack of insulation you calculate similarly and comes out to be 8.86% of the total energy input. And the energy out with the water that could be reused with the next cycle came out to be 47.23%. Essentially, the results indicate that this water blancher operates at 44% thermal energy efficiency. The way that that was calculated is that the actual thing that you are trying to accomplish is the blanching of the lima beans, and that is the amount of energy that actually went into the product or the lima beans, as opposed to the amount of energy that went into heating the water and also to losses through the insulation. So that's how that's calculated. Our next topic, rate equation and the use of a spreadsheet. There are a couple different sections of the book where we will be using the rate equation, and if you're familiar with calculus, if you've had it before, then this should be no surprise to you. But there's a couple different instances where we actually will use rate equations. Flow rate is one instance. Also, there's Ohm's law, Fick's law, Fourier's law that we will also use within the context of this book. Also, there will be extensive use of spreadsheets in this course. If you are not familiar with using a spreadsheet such as Microsoft Excel, it is suggested that you go through whatever you need to do, find a book, learn how to use one, but spreadsheets are set up as rows and columns, and they help us to do mathematical calculations, and a spreadsheet is an invaluable tool. Here we have an example of a format of a spreadsheet, which is calculating out a large set of calculations that you might use in this class. There actually is a section where we'll be doing integration by parts, but we won't be doing it by hand. We'll be using a spreadsheet. It is possible to do it by hand, but it's an awful lot of calculations to keep track of. But setting up a spreadsheet will help you in these kinds of larger calculations. Here are a few of the features of spreadsheets. Functions for calculations are things that you're able to do. Logical, mathematical, statistical, financial, string, date, time, etc. You're able to embed these in a spreadsheet for it to actually calculate those out for you. Also, you'll have different graphing capabilities. Be able to do a bar chart, a pie chart, a XY graph, a line graph, or 3D graphs. The XY graph or scatter plot is something that you'll use extensively in this course. Not so much line graphs. They can have multiple pages. You can also do a 3D effect. They can also produce and play slideshows, and you can import and export data and text from other software and spreadsheets. One of the other advantages to spreadsheets is that they are able to actually do simple regression analysis. That is to say that if you plug in points from data, it can actually give you the equation of the line that fits that data. Also, there are limited database activities, and though we won't use that particular feature in this course, it is a very, very useful feature, and you may wish to learn. This concludes the lectures for Topic 1, Problem Solving. This is the conclusion of Lecture 404. If you have any questions, please contact me at the email address listed in the syllabus. Thank you. Goodbye.